We're on page 2 of differentiation rules addendum. First, we're going to finish up the last exercise. It says find the gradient of the tangent to x plus y cubed equals 4y. And you just have to remember that when you have a request for something like gradient of the tangent, what they're just asking for is the derivative. Okay? So remember, the tangent line is a straight line that hugs the side of a curve, and the gradient of it is the slope of it, and the slope of the tangent is the same thing as the derivative. Okay? And they're asking for the derivative at a specific value. So the first step is to actually find the derivative using implicit differentiation, because if you look at this, it's difficult to separate the y's from the x's, so it's easier just to do implicit differentiation. And once you find the implicit derivative, you make sure that you have dy dx on the left side and everything else on the right side, and then you can substitute in the appropriate value of y and x, and then you'll get a numerical value. That's what they want. Okay, when they say find the derivative at a certain point, at a certain coordinate, they want you to actually give a number. Okay, so first thing we're going to do is we're going to take the implicit derivative of x plus y cubed equals 4y. So remember that we're taking the derivative with respect to x, so the derivative of x with respect to x is 1. The derivative of y squared with respect to x, 3y squared using the power rule, but then we need to take the chain rule of what's inside the power, which is y, so we multiply that times dy dx. Okay, if the inside was just x, we wouldn't need to do the chain rule because the chain rule on x is just 1. And the right side is 4y, right? So the derivative of 4y would just be 4 dy dx. Okay. Now we want to put dy dx by itself on the left side. So let's group the terms that have dy dx on the left side. Anything that doesn't have a dy dx, move it to the right side. Subtract 1 from both sides, and we'll end up with the 1 on the left side is negative 1. Subtract 4 dy dx from the left side, and then we'll have 3y squared dy dx minus 4 dy dx. Let's factor out the dy dx, and so we'll have dy dx 3y squared minus 4. If you don't get that, go ahead and do the algebra one step at a time, and you'll see that's the way it goes. And then we're going to divide both sides by 3y squared minus 4 to get dy dx by itself, because we want to know what dy dx is. 3y squared minus 4. And then we're going to evaluate this at y equals, what was it again? Y equals 1. Now, let's see. Oh, and there's no x's, so that's great. All right, so let's see. If we evaluate at y equals 1, we'll have negative 1 over 3 times 1 squared minus 4, which is negative 1 divided by 3 minus 4, which is negative 1 divided by negative 1, which is 1. So the derivative, or the gradient of the tangent at y equals 1 is 1. Okay? Let's go to 18f, which is derivative of exponential functions. Just some of the problems at the end, which were a little bit more difficult versions of what the SL people do. One thing in particular is taking derivatives of things that don't look like e to the x, which is 2.71 to the x. What do you do if the number in the base of the exponent is not 2.71? Okay, so here we have an example where the function, the exponential function, has a base that is a positive number a, but it doesn't happen to be e. So the trick here is to rewrite a as e natural log of a, right? If you write e natural log of a, that's the same thing as a, because e to the x and natural log of x undo each other. So if you do both of them on a, you just get a back, right? So if you substitute that in for a, we end up with this expression, right? E to the natural log of a to the x. And then now that we have these two exponents next to each other, we can multiply them. So we do that, natural log of a times x. And now we're going to take the derivative, because we do know how to take the derivative of e to the x, whereas we did not really know how to take the derivative of a to the x, right? So the rule to take the derivative of e to the x is e. You just rewrite the function as it is written, right? Which is like that. And then you do the power rule of what's in the exponent. Remember, natural log of a is not a function, it's a number, because a is just a constant that we don't know what it is yet. So if you take the derivative of natural log of a times x, basically what you get is natural log of a, because imagine it was like 3x. What's the derivative of 3x? 3. So what's the derivative of natural log of a times x? It would be natural log of a. Okay? That's it. All right. Find the gradient function for f of x equal to, okay, so now they're just giving us some very advanced functions here. And what you want to do is you want to use chain rule. So first you look at this, and I think it's easier to rewrite these as negative exponents, because then it's pretty obvious how you use the power rule. Hopefully there'll be less chance of making a mistake. And so like, for example, this one, I would rewrite it as 1 minus e to the 3x to the negative 2. You see why, right? Because it's 1 minus e to the 3x squared inverted, okay? And once you have it rewritten like this, then you have to take the derivative. We haven't taken the derivative yet. All we did was rewrite it. It's just an equivalent expression. Now we're going to take the derivative. When we take the derivative, we do the power rule. So we take the exponent, we put it out front, and then we rewrite the inside. And then we decrease the exponent negative 2 to negative 3. And then we have to do the chain rule on what's inside. So what's on the inside? 1 minus e to the 3x. How do we do the chain rule of that? The derivative of 1 is just 0. The derivative of negative e to the 3x is negative 3 e to the 3x. So if we want to rewrite it as a fraction, we could rewrite it as, let's see, negative 2 times negative 3 is 6. On the top, we're going to have e to the 3x, and on the bottom we're going to have 1 minus e to the 3x cubed. Okay, and that's our answer. Let's move on to C. Again, let's rewrite this as a power, because it's a little bit easier to work with powers than roots or inverted powers. And then that is to the 1/2 power, right? Okay, so, to confuse things, this is also a product, right? So, which one's on the outside, the product or the exponent? The product's on the outside, right? So we're going to have to do the product first. So basically what we're doing is, let's take the derivative of u times v, right? Where u is x and v is this big thing here. So we're going to do that first. So it would be u v dash plus u dash v. Doesn't really matter which order you do it, right? 1 plus 2 is 2 plus 1, right? So we're going to do x times the derivative of that big binomial. And that would be negative 1/2, because we have to decrease the power by 1. And then we do the chain rule to the inside, and we get negative 2. We actually get positive 2 e to the minus x. And then we do u dash v. U dash would be derivative of x, which is just 1. And then we just repeat this big expression here to the 1/2 power. Okay, and I don't think you can simplify this too much. What we can do is maybe like cancel out the 2's, rearrange this as a fraction. I'm not going to put the square root sign. It doesn't really change anything, right? Okay, so I think that's what we get, and maybe you can't simplify that anymore. The answer in the back of the book, they just put it over common denominator and combine the numerators, not really improving how simple it looks or anything. Okay, let's go to 8a. Find the derivative for 2 to the x. Okay, remember that we don't know the derivative of 2 to the x, we only know the derivative of e to the x, so we want to express 2 to the x as e to the x. The way we can do that is we could say, well, 2 is equal to e to the natural log of 2, right? Because e and natural log undo each other. Basically, you'll get 2 back, right? So let's rewrite it as e to the natural log of 2 to the x. And then we'll say, hey, why don't we multiply the two exponents together? So then we have x natural log of 2. Remember, natural log of 2 is just a number. Now we're going to take the derivative. When we take the derivative, we're going to rewrite the expression, the exponential expression. Since the exponent is not just x, we need to do chain rule. What's the derivative of a constant times x? It would just be the constant, and in this case, the constant is natural log of 2. Okay, so that's it. What about c? So c is a little bit more complicated because we have to use product rule, right? The last thing done here is the two things multiplied times each other. So first we'll do u, which is x, and then we'll do v dash, which would be 2 to the x. Wait, 2 to the x looks, the derivative of 2 to the x is that, right? So we'll have natural log of 2, e to the x natural log of 2. So that's v dash, right? Then I'm going to do u dash, which is 1, times v, which is 2 to the x. So there it is. One thing they do to the answers in the back of the book is they remember that e to the natural log of 2 is the same thing as 2, right? So they rewrite these exponents here using that fact. So what if we switch the order of x and natural log 2? Then we'd have e natural log of 2 times x, right? And then we still have this coefficient natural log of 2. Now, we can group e to the natural log of 2, that's equal to 2, right? So then we can get 2 to the x back, just like we had at the beginning. So you could rewrite it like that, right? So every time you see e to the x natural log of 2, it's the same thing as 2 to the x, right? So you could write it like this, x natural log of 2, 2 to the x plus 2 to the x. Okay, maybe that looks nicer. All right, moving on to number 9. Find dy dx if, oh my gosh, look at that big expression there. We are going to use implicit differentiation because we got the x's and y's mixed here. And we're going to use our exponential differentiation rules, right? So we basically have 3 terms, and although they look pretty bad, if you stop and think about it, they're just added together. So we're not even going to do product rule. We're just going to take the derivative of each one of the expressions, and each one is not so bad. Oh, wait a second. But within here, we do have some product rules going on, right? We have x cubed times e to the 3y. Those are 2 variable expressions multiplied together. So we do need to do product rule a little bit, okay? So let's say that x cubed is u and e to the 3y is v. We're going to have x cubed times the derivative of e to the 3y, which would be e to the 3y, power rule, 3d, not power rule, chain rule, 3 dy dx, because 3 dy dx is the derivative of this exponent, right? And then we need to do u dash, which would be 3x squared, times v, which would be e to the 3y. And then we need to do the next term. So the next term would be, it also has power rule because it's got x squared times y cubed. So we'll have 4, which just stays out there in front as a coefficient. And x squared would be the u value. Derivative of y cubed, it would be 3y squared dy dx. And then we add that to the 4 times the derivative of x squared, which would be 2x. And then we put the v value, which is y cubed. And then on the right side, we're going to have, this is actually not such a bad derivative, 27 just stays out front. And then e to the negative 2x, and then we take the derivative of the exponent, which is negative 2x, derivative is negative 2, right? Let's see if this simplifies at all. We'll just rearrange it so the coefficients are maybe in front. 3 x cubed e to the 3y dy dx plus 3x squared e to the 3y plus 3 times 4 is 12, x squared y squared dy dx plus 8x y cubed equals negative 54 e to the negative 2x. Now what we want to do is we want to take anything that has dy dx in it, or y dashed, and we want to group it together on the left side, and then we put everything else on the right side so we can isolate dy dx. So we're going to put these two terms on the left, or we're going to leave them on the left, and then we're going to move these two terms to the right. So when these two terms that are going to stay on the left, we can factor out the y dash. So we'll have 3x cubed e to the 3y plus 12x squared y squared times dy dx. And then we're going to move everything else to the other side. So we have negative 54 e to the negative 2x. We're going to have minus 3x squared e to the 3y. And we have minus 8xy cubed. And then we're going to divide both sides by this so that we can isolate the dy dx. And then we're just going to make a giant fraction. So we got negative 54 e to the negative 2x. We got negative 3x squared e to the 3y. We got, negative 8xy cubed. And then all this is going to be divided by 3x cubed e to the 3y plus 12x squared y squared. So that's it. In the back of the book, they did factor out like 3x squared from the bottom, but it doesn't really do anything. Okay, and they also factor out a negative sign on the top. So they have negative, and then they have parentheses, and they have everything added together inside. No difference. Okay, that's it.